Today in pre-cal we learned some about graphing, or at least reviewed those concepts from Algebra 2. In this case we're only talking about graphing functions and some ways to help us do that. The first thing we covered was how to find solutions of functions. For example, if f of x is equal to 10x minus 7, and I ask you to find f of 2 and f of negative 1. To do that, you would do the process twice. For f of 2, you would plug in 2 for x, so you would do 10 times 2 minus 7. 10 times 2 is 20, minus 7 is 13. So my answer would be 2, 13, because 2 is my x value and 13 is my y value. If I was trying to find f of negative 1, I would plug in negative 1 everywhere that I see x. And I would do 10 times negative 1, which is negative 10, minus 7, which is negative 17. And that answer would be negative 1, negative 17. And I would have two answers. Sometimes finding solutions can help us to graph things because they give us specific points. Sometimes we write things in function notation, or we find graphs like this to find some specific information after someone else has already modeled that pattern using a function. The second thing we want to talk about today, part B, is simply graphing. The main way we do that, as I already mentioned, is to plot points. And the other two ways are to find the intercepts and to look at the symmetry. You may be thinking the easiest way to graph is to use a calculator, and you would be right, but there's some value to knowing how to do this without the calculator and to understanding some general things about functions. So we've already talked about plotting points. Let's talk about intercepts. The first point that should be made is to find the x-intercept. You plug in 0 for y. And to find the y-intercept, you plug in 0 for x. Once you've done that, you should be able to solve and get us some points. For example, number 2, if y is equal to x to the third minus 4x, and we want to find its intercepts to help make it easier to graph. The first thing I would do is to start with y equals, and in place of x, I would put 0. Everywhere that I see an x. 0 to the third power is 0 minus 4 times 0, which is 0. So far we have 0 minus 0, which is 0. When I plug in 0 for the x value, I get 0 as the y value. So that is my y-intercept. In fact, it is also an x-intercept because there's 0 in both places. I still need to find my other x-intercepts. So the second part of my process is to say 0 equals, plug in 0 for y, x to the third minus 4x. To get x solved for, I want to factor out x to the third minus 4x. I can factor out x because that's what they have in common. And what remains is x squared minus 4. And then if I leave the x on the outside and have x squared minus 4, I can also factor that into x minus 2 and x plus 2 because that's the difference of two squares. And then I set each factor equal to 0. Once I set each factor to 0, I can see that my intercepts are 0, 0, 2, 0, and negative 2, 0. And if I plot those points, I'm one step closer to getting my graph. That's really all there is to intercepts. The last thing we want to talk about today is symmetry. And when we're dealing with symmetry, there are three main types. The first is with respect to the x-axis. And that WRT is with respect to, it's just shorthand. With respect to the x-axis, there is symmetry if when you replace y with negative y, and I'm going to go ahead and put that in parentheses because you're actually physically moving the y and putting negative y in its place. If when you replace y with negative y, you get the same equation as the original. Then you know that you have symmetry with respect to the x-axis. You have symmetry with respect to the y-axis if when you replace x with negative x, same thing, you get the same original equation back. Lastly, you have with respect to the origin, if both of these things occur. So this is kind of like intercepts. It's a two-step process. You'll have to check when you plug in for negative y what happens, and then you have to check when you plug in for negative x what happens. And if both things yield the original problem, then it has symmetry with respect to the origin. So I'm just going to put if both occur and an arrow up so that you'll know if both of these things happen, it has symmetry with respect to the origin. Let's look at an example of what that might be like. Example number 3, x minus y squared equals 1. Again, we're going to follow the process through twice. So let me start with x minus, and in place of y, I'm going to put negative y. And everything else stays the same. Now, the order of operations tells me negative y squared, something squared, gets rid of the negative. So I have x minus y squared equals 1. X minus y squared equals 1 was the original, so I know that there is symmetry with respect to the x-axis. For sure. Yes or no is not a good answer here because I need to know yes what or no what. Okay, watch out here. If you don't use the order of operations properly, it would be very easy to change negative negative here to a positive, which would not be the same as the original and would yield a wrong answer. So watch out for that. Let's test with respect to the y-axis. So if I change my x to negative x, leave everything else the same. I want to see if I can solve anything there. There isn't anything to do with the parentheses, so if I just drop those completely, I get negative x minus y squared equals 1, and that is not the original, so there is no symmetry there. The last thing I think has value for us to do is to just do a quick sketch of this using the information we already have, since we want to see what with respect to the x-axis symmetry really looks like probably. Let's start by doing x minus y squared equals 1. Let's solve for y. We want to use our inverse operations, so we subtract x from both sides. We have negative y squared equals 1 minus x. We want to get rid of the negative, so we flip all of our signs. And then y squared equals x minus 1. I'm just going to invert that to look more normal for you. And then I'm going to take the square root of both sides. Remember, when I take the square root, I have to take the positive and minus of that value. Now I'm going to plot some points. It'll be helpful for you to remember that right here you cannot choose a negative number or a 0 because you cannot take the square root of a negative number, or at least you can at this time. So values in what's called our domain, if that word is still in your brain, our x values that would work are maybe 1, 2, and 5. And in a second it might make more sense why I chose those. If I plug in 1, 1 minus 1 is 0, and the square root of 0 is 0. 2 minus 1 is 1, and the square root of 1 is 1. 5 minus 1 is 4, and the square root of 4 is 2. So I have 3 good points. Now I want to plot those. So I have 1, 0, 2, 1, and 5, 2. My symmetry tells me it's around the x-axis, so I can plot the points that mirror my first part. And now I can see what my graph should look like. I hope this lesson has been valuable to you and you've learned something. If you have questions, be sure to contact me in tutorials. The assignment for this is A2, and it's a worksheet that should be in the absent folder ready for you to try.